So on to something a little bit different. Find the rational function with each set of characteristics. So we've got the vertical asymptotes being given, horizontal asymptote, x-intercept, and if there's any holes. So the holes are going to tell us, is there anything that's being canceled? And so no cancellation. Now let's start with maybe the more obvious one, the vertical asymptotes. Those are easy because those just occur wherever I have a MPV. So if this is at x equals -2, then I'm going to have x plus 2 and x minus 4. Meaning if x is -2 or 4, we're gonna divide by 0, which we can't do. So therefore there'll be an asymptote there. Okay, that one's not so bad. But then how do I get this vertical asymptote? That one's a little bit trickier to think about. So let's just go on to the x-intercept before we do anything with that. The x-intercept is going to occur at -3 and 5. Well, how do we make sure that it's at that? Like, how do I do that? Well, one thing we know is that at the x-intercept, the height is always 0. So if I let y equals 0, so then the numerator, we still don't know what that is. But what's going to happen here is I'm going to multiply both of these by both sides by x plus 2 times x minus 4. So I'm going to be left with just x equals whatever the numerator is. So actually, I'm just going to put here, well, what factors? This is one factor, this is the other factor. This is going to be x plus 3 and then 5. Or x minus 5, sorry. Because if I was to actually go and solve this right here, well, x would be -3, which we have, and x is 5. Perfect. So far, so good. Now we have the numerator and the denominator of the same degree. So now we're looking for leading coefficient divided by leading coefficient. Well, right now, if I actually FOILed this out, I would end up with it being x squared dot dot dot. That's the only one that really matters, over x squared dot dot dot. And actually, I'm okay with that. That's what I want. So therefore, I would leave this because 1 divided by 1 is 1. And so we're good. All right, our next question is very similar to the last one, but this time we're just looking off of graphs instead of a table. So find the rational function shown in each graph below. I like starting with the MPVs. They're nice and easy. So if I look right here, I've got one at -4. So this is x equals -4. And this one's at x equals 2. Meaning that I must have in the denominator an x plus 4 and a x minus 2. Okay, that solves that part then. Next is going to be my x-intercept. Or sorry, yeah, my x-intercept. And right now I see that's occurring at +1. And so, or sorry, -1. Which means it's going to be x plus 1 as my numerator then. And that's actually it for this graph. We have y equals x plus 1 over x plus 4 times x minus 2. Now for our second one, we've got a little bit more going on. You can see we've got a horizontal asymptote that's been shifted up. So we know something's happening there. We've got a point of discontinuity here as well. But I'm going to start in the same place. I'm going to start with my asymptote. So I have one occurring right here, and that's at y equals -2 or x equals -2, meaning my denominator is going to be x plus 2. Now there is actually another one because I have a point of discontinuity here, which means something canceled. And this canceled when x was -3, which means at my denominator at some point I had an x plus 3 there. But if it was able to cancel, that means it also was in the numerator as well. Okay, so that solves that problem. Now to get this shift up 1, that means I must have had something go 1 divided by 1. Or 2 divided by 2 or something to that effect. I'm going to assume it's probably 1 divided by 1. It's a little bit simpler. And we can also look at our x-intercept. It's happening at 0. That's a really weird one, which tells me I just have an x here. Because again, if I let this equal to 0, I multiply both sides by x plus 2 and times x plus 3. And the only way to get that is x equals 0. So that to me looks like our graph. If we double check though that we do have a coefficient, leading coefficient of 1. So x times x is x squared. Yep, that's going to be single x squared. X times x is x squared, single x squared. So therefore our leading coefficients are 1. It matches all the criteria that's there. All right, one last example. Find the rational function shown below in each graph. It looks very similar, except for here, we actually end up with a linear function. So my favorite strategy of, I'll look for the asymptotes, put those on the denominator. Not going to work here. We do have some points of discontinuity, though. So this one looks like it happens at, what is that, 1, 2, 3, 4, 5, 6. So if that's at x equals 6, that means we have a factor of x minus 6 in both the numerator and denominator. And here, this looks like it's at negative 4. So that means I'm going to have a factor of x plus 4. That would have canceled out somewhere along the way. And all we're left with then is having our x-intercept. Now that looks like it occurs at 1, 2, 3. So that's negative 3. And so that means if my factor should be x plus 3. So when I'm solving this, now let's just take a second to think about, does that make sense? So if I was to cancel out these, I would be left with y equals x plus 3. Now that is linear, yep. And it would have a y-intercept of 3. Yes, perfect. So therefore all of this makes sense, and based on the information we have. And it would have 2 holes in the graph as well.